In 2012, NASA predicted the collision with near certainty. Not a projection, not a possibility, a near certainty. Then 100 simulations turned it into a coin flip. The gravity matrix. Today, we investigate how one of astronomy's greatest certainties unraveled. We track this from Helsinki preprint to publication. NASA published this prediction with the confidence of settled science. The 2012 paper, peer-reviewed, published, updated the textbooks. What nobody counted, a 32 million light-year dark matter sheet. Andromeda approaches at 110 kilometers per second, radially. The uncertainty, Andromeda's sideways drift, its transverse velocity. Gaia EDR3 measured it at 80·4 km/s, error bar 31.2. That error bar is the hinge of the entire question. Roland van der Merel led the 2012 prediction at SCI. His team used only Hubble measurements, the best then available. The 2012 model treated it as essentially a two-body problem. The Milky Way and Andromeda, two giants, one gravitational equation. What the model excluded took 13 years to account for. Hubble measured expansion in 1929 and was off by 7-fold. Calibration errors are not failures, they are science working. But 13 years of textbook certainty carries its own gravity. From Earth, Andromeda spans 35 degrees, 7 moons wide. In 375 billion years, it would dominate the night sky. Earth becomes uninhabitable in 1 billion years. Galaxy survival belongs to time scale that dwarfs civilizations. Yet the physics determining that outcome just changed. What caught our attention? The methodology, not the headline. Not the headline, the variables they chose to model. 2012 modeled two bodies. 2025 modeled the full local group. That methodological choice is where the certainty died. The simulations found something more unsettling than the headline. Sawala had run 999 simulations when the final result emerged. He read the number twice, then checked the methodology again. 50%, not 94, not a near miss, a coin flip. Researchers at Durham, Toulouse, and Western Australia collaborated. Two incompatible numbers. Which century of astronomy is wrong? The answer. The 2012 model excluded the satellite galaxies. The Large Magellanic Cloud, 1/7 our mass, perpendicular orbit. It may be on its first orbit, recently captured. Dr. Gertina Bisla at Arizona mapped the LMC's gravitational influence. The LMC actively distorts the Milky Way's dark matter halo. That distortion shifts our center of mass and our trajectory. On Andromeda's side, M33, the Triangulum galaxy, pulls toward collision. Two dwarf galaxies pull opposite ways on a trillion stars. N-body simulation captures what two-body models fundamentally cannot. The 2012 team got one right: Doppler confirmation of approach. Andromeda is coming. The debate, collision or near miss. If this reshaped your view, subscribe for the next dataset. Gaia measured Andromeda's proper motion to 7 microarcseconds yearly. That equals measuring a hair's width across the Atlantic. Even Gaia cannot resolve the transverse velocity precisely enough. In our assessment, the most significant limitation in galactic dynamics, a 15% mass dwarf may decide the fate of everything. The LMC orbit was absent from every pre-2020 model. Nobody included it. Orbital data did not exist yet. Nydia Calavealil at Virginia used Gaia to map the LMC. Her data suggests the LMC is on its first infall. A newly arrived gravitational actor, never modeled, now decisive. The most studied galaxy pair had a hidden actor. Consider that. If this event had a hidden actor, what else does? Paris Observatory found Andromeda's mass may be significantly lower. Less mass means less pull. The coin flip tilts further. Andromeda's mass error bars are large for our nearest neighbor. Paris found a possible dark matter deficit in M31. A dark matter deficit in any major galaxy demands explanation. 3 independent studies all point away from certainty. Away from certainty, toward genuine, unresolvable uncertainty. The objection: Gaia's future releases will shrink these error bars. Probably true, but a second discovery changes the framework entirely. One no-reference treatment of this topic has yet included. January 2026, Groningen's Kaptein Institute published in Nature Astronomy. Uod Wemp found something hiding around our entire local group. A dark matter sheet, 32 million light-years across, embedding everything. 32 million light-years. Our local group is a minor feature. Dark matter sheets are the cosmic web's flat structural nodes. Consider what this means. We were embedded in this all along. The sheet explains why nearby galaxy groups move in coordination. Virgo groups always move together. Now we know why. The dark matter sheet goes beyond simple gravitational attraction. Both galaxies' trajectories sit inside this sheet's gravitational potential. No treatment has integrated this. It changes the boundary conditions. Of everything covered this quarter, this made us rewrite everything. We don't know yet. That uncertainty is the point. Honest position: 50-50 is the best number we have now. The sheet is peer-reviewed. Collision model integration not yet done. Integration runs within 3 years will shift the number. January 2026 changed the picture in ways still being processed. Our entire local group sits in a 32 million light-year sheet. 32 million light-years, invisible, structural, influencing every calculation. Wemp et Kaptein published in Nature Astronomy, January 27, 2026. Coordinated nearby galaxy motion now has a structural explanation. More variables make the calculation harder and more honest. Step back. What actually happens if the galaxies collide? First closest approach. For 3 billion years, not a collision yet. Stars rarely collide in galaxy mergers. Distances are too vast. Gas, dust, and gravitational architecture collide, not the stars. Gas compresses. Stars burst into formation. That is the starburst. Stars flung into new orbits. Galactic architecture reorganized over billions. Multiple passes over billions of years, each drawing them closer. End state at 10 billion years. Milkomeda, a massive elliptical. 1.2 to 1.4 trillion stars, the combined local group. Milkomeda's most dramatic event comes 16.6 million years post-merger. At the Milky Way's center, Sagittarius A star 4M solar masses. Andromeda's nucleus holds 100 to 200 million solar masses. Dynamical friction draws the two black holes together inside Milkomeda. They spiral in, emitting gravitational waves. LISA 2035 detects them. That SMBH merger releases more gravitational wave energy than anything before. If gas remains, the merged SMBH may ignite a quasar. A quasar outshining every Milkomeda star for tens of millions. Any Milkomeda civilization then lives under a permanently blazing core. Here is the question no one asks: what if the miss is worse? Here is the framework, what to watch for now. Gaia DR4 in 2026 delivers more precise Andromeda satellite data. If DR4 narrows the error bar significantly, watch which direction. Lower probability, 3070 or 2080, the LMC deflection scenario dominates. Higher probability, 2012 was right, just imprecise about the timeline. Either outcome matters. The coin flip is the scientific news. Biggest prediction revision since the Hubble tension opened in 2014. Better instruments found the missing variables. Both cases show this. Certainty collapse is the defining experience of 2020's cosmology. Sagan science means not fooling ourselves. Helsinki confirms it. Better instruments, more variables, different answer. That is progress. We may never settle the Andromeda question definitively. That's uncomfortable. The transverse velocity error bars may outpace current instruments entirely. The sheet may compound the uncertainty rather than resolve it. The universe does not yield neat answers on human timescales. Andromeda is approaching, collision or pass-by still unknown. The LMC was ignored, whether its influence is decisive, unknown. A dark matter sheet exists around us, collision effect, unknown. Not failure, frontier science's honest position. The Andromeda question sits within a far larger context. We sit in Laniakea, spanning 520 million light-years. The Andromeda question is local drama inside incomprehensible structure. It tests whether our models of the universe actually work. 2012 failed not from wrong physics, but from incomplete models. Newtonian gravity holds, general relativity holds, the physics is right. Missing true positions, masses and velocities of all relevant bodies. Still incomplete, sheet integration unrun, DR4 unpublished. Frontier astronomy, answers change when the data changes. We update this when DR4 and sheet models arrive. When the coin flip resolves, subscribe and be there. Iron in your blood was forged in a dying star. Milkomeda's starburst will seed a new generation of planetary systems. A pass-by still triggers tidal reshaping of both galactic disks. Collision matters for Milkomeda, less so for tidal effects. Either way, our galaxy looks different in 5 billion years. Look up at the Milky Way. It moves toward uncertainty. Andromeda's uncertainty is not ignorance. It invites closer attention. We track every dataset and preprint at the gravity matrix. If this changed how you see the sky, stay. Next, the Hubble tension, a deeper crisis than this.